Kirkwood Math. All right, ladies and gentlemen, you have reached the video where we're going over 7.2. We're doing part 2 with part 1 with fractions. Okay, so grab your notes, settle on down, and we're going to go over how to solve equations with rational numbers like fractions by multiplying the equation by the LCD to eliminate the denominator, okay? But keyword is we're going to figure out how we can get rid of our fractions and turn them back into regular equations with whole number terms. All right, so the first thing you need to do is copy down these vocabulary words. Pause the video, copy them down. When you're done copying them, play this video so you can hear me explain that an LCM, which is a least common multiple, should be something you've heard before. It is a review term, but if not, it is basically what it sounds like. It is the least or smallest number that two or more numbers have in common when you look at their multiples, and we're talking skip counting. So when I skip count by numbers, I want to know which one they have in common, which smallest number. Your LCM is used to find your LCD, which is your least common denominator. It's basically your LCM, but for fractions. I want to know what's the LCM of the denominators. Your terms, you're going to be asked to multiply each term. Terms are separated by addition and subtraction signs. So just keep track of each of your terms, each of your addition and subtraction signs, so that you know what you're separating your problem into and how many times you're going to multiply. Okay, so here's an example of LCM and LCD. You can see here that we're going to find the LCM of 3 and 4. So we're going to skip count by 3s, we're going to skip count by 4s. The smallest number they have in common is 12, so our LCM is 12. Our LCM is the same thing as LCD. The only difference is instead of getting random numbers, you're going to pull them from the denominators of fractions. So if I want to find the LCD of 1/5 and 2/3, I would skip count 5 and skip count 3, and I'd find that the smallest number they have in common is 15, so my LCD is 15. Now we need to know that because the first thing that we're going to do in our step to get rid of these fractions is to find the LCM of all the denominators. Let me make sure my pen's on. There we go. All the denominators, okay? So I'm going to use 10, 2, 5, and then remember that all whole numbers have a denominator of 1. And I'm first going to find the LCM of these numbers. So you can do this in your head, and you might already be saying, but Miss Kirkwood, it's 2. No, sorry, Miss Kirkwood, I'm trying to write it too. But Miss Kirkwood, it's 10, and you would be right. The LCM is 10. But I'm going to show you what that looks like in case you don't remember how to do that. So I'm just going to skip count by my numbers. I'm going to skip count 2, 4, 6, 8, 10, and 5, 10, 15. And then I am going to go ahead and circle. Let me pick a different color here. The numbers that they have in common. Oh, this pen's real big. Let's see. There we go. So 10 is the smallest number that all three have in common. I'm not going to worry about the 1 because our 1 here, it does all the whole numbers. So I don't have to write 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I know that 10 is included as a multiple of 1. Okay, so now that we know that our LCD, our least common denominator, is 10, we can go ahead and look at our next step. So step 2 is going to have you multiply all of your terms here, all your terms by the LCD, and this will eliminate our denominators, okay? So I'm going to rewrite my problem over here, and I'm going to show you all the steps. Now, remember, you can do some of these steps in your head, but you do need to write all versions of your equation as you move down. You can't do the whole problem in your head. You got to write out something. Okay, so I'm going to go ahead and multiply all of these by 10, okay? This times 10, this times 10, all of them by 10 over 1, all these whole numbers. Okay, now once I multiply them out, I'm going to say, okay, 10 times 7 is 70, 10 times 1 is 10, so this is 70n. 10 times 3 is 30. 2 times 1 is 2. 3 times 10 is 30. 5 times 1 is 5. And 2 times 10 is 20. Okay? But remember, our goal is to eliminate the denominators, and I haven't done that yet. So now I'm going to simplify all of my equations, all my fractions, so that I can get rid of those denominators. 70 divided by 10 is 7. So my first term is 7n. 30 divided by 2 is 15. 30 divided by 5 is 6. And 20 just stays 20. Now, if you can go from this step straight to that step, you are absolutely welcome to do that, because you could probably do all of this in your head. If you need to write it out, please do that. That's okay too. I'm just showing you all the steps. All right, the last thing that we're going to do is now solve. And this is the exact same thing that we've been doing in class, okay? I'm going to get all my variable terms to one side, all my constants to the other, and then I'm going to find an answer for n. The only thing is this looks a little bit different. So if you notice on the right-hand side here, I have no variable term, only constants. And because they're on the same side of the equal sign, I can just combine those like terms and add. 6 plus 20 is 26. The rest of this comes down. And now I can solve my problem. I'm going to get rid of this 15 on both sides. And I'm left with 7n equals 11. I'm going to come over here. 7n divided by 7. That means that n is going to equal 11/7. And it's okay to have a fractional answer. That's okay. All right, so let's try it again. Okay, so I'm going to do the same thing. I'm going to find the LCM of my denominators, but the only numbers I have is 7 and 1. So the LCD of 7 and 1 is just 7. So I'm going to go ahead and multiply everything by 7. So 1/7 k minus 6, 3/7 k plus 4. And what I'm going to do is I'm going to go ahead and multiply everything by 7. This is times 7. This is times 7. Everybody gets a 7. Okay, I'm going to go ahead and do this step in my head. I know that these 7s cancel out, so I'm left with just 1k. Keeping my negative here because negative 6 times 7 is negative 42. Then I have 3/7 times 7. Again, these 7s cancel out, and I get 3k. And then I'm going to add 4 or multiply 4 times 7, which is 28. So here's my new equation there. I'm ready to go ahead and solve. So I'm going to get rid of k on both sides. 1k. Remember, this negative is part of this term, so this is actually negative 42. And this is 2k. I can now subtract 28 on both sides. And I'm doing a negative plus a negative, same signs, add and keep. So I'm going to add them together and keep the sign. So that's 10, 5, 6, 7. This is negative 70 is equal to 2k. Divide both sides by 2. And I'm going to get negative 35. K is k. And that's my answer. All right, for these last two problems, I want you to pause the video and try them on your own first. Then when you come back, I will have done the problems already, and you can just check my work and see, and I'll make any comments on if there was anything special about these two problems. All right, welcome back. Hopefully you took some time to do those problems. Let's take a look. So I found the least common denominator of this of 6, 2, and 4. And that's 12, and I showed you over here why it's 12. If you got a bigger number, that's totally okay. Even if it's not the least common denominator, as long as it's a common denominator, it'll still work. You just will get bigger numbers, okay? So I multiplied everything by 12. I cross-canceled If you need to actually do 12 times 5 divided by 6, go ahead and do that. But I know that 6 goes into 12 2 times. So I got 10y plus 12 equals negative 6y. Don't forget that negative, plus 3. I then solved my problem and I got negative 9 over 16. When dealing with fractions, you're not always going to get really happy, friendly numbers, and that's okay. As long as you know that that's okay, and you don't feel as though that problem is wrong just because of the answer. All right, on the other side, the LCD of 3 and 5 is 15. I went ahead and multiplied everything by 15. Again, I cross-canceled. I got 5x plus 150 equals 9x. I then subtracted 5x and solved, and I got 75 halves. Now, 150 over 4 is not incorrect, but if you can reduce the fraction, you don't have to make it a mixed number, but if you can reduce the fraction, that's what you want to do. So I did 150 over 4 divided by 2, and I got 75 over 2. If you wrote 30, what is it? 30 something. Hold on. What was my other answer? Let me look. If you got 37 and a half, that is also correct. But you did not have to turn it into a mixed number if you didn't want to. All right. Good luck on your homework, and I hope that works out.